Right, chaps. Someone did ask how these swimming pool heaters work, so I've just wrapped up working on one here. So I'll just go through it quickly. Just the fundamentals first. You can see the two pipes down there, one at the bottom there, and one at the top. Water goes in the bottom and comes out the top. That's the swimming pool water, and that all goes through this heat exchanger. There's another video where I've chopped one of these apart, so you can see what's in there. So that's that one. We got another coil as well. This one's under that metal grid, but you can see there's pipe work to it there. In this case, we'll call this the evaporator because refrigerant's going into it and evaporating. Might call this the condenser because refrigerant's going in there and condensing. But the way it goes through here's our compressor. That's the discharge from the compressor. So we'll start with hot gas, hot refrigerant coming through here. There's a pressure switch. If the pressure goes too high, that switch goes to a circuit board and cocks it off. When it comes through to this gizmo, that's a four-way valve, reversing valve they're called sometimes. So you've got four connections on there. Pretty simple operation. The solenoid valve just operates a slide inside the unit itself. So you've got discharge going in here. This other one here is the suction going back to the compressor. And it's either operating, connecting these two together, and obviously the discharge at the top and an outlet here, or it's connecting these two together and the discharge at the top and the outlet there. There's a slide that goes in between with a couple of plates either side, so it forces the refrigerant basically through these two or those two, and then the other side of it, the refrigerant goes off as well. So in this case, our compressor discharge, the discharge of the compressor always goes to one up on its own. The suction back to the compressor is always the one in the middle. So the discharge is coming in here from the compressor and is coming out here. So this is hot gas still from the compressor, nothing else has changed on it. And it's going in to the heat exchanger where the water is there. So hot gas is going in there, it's going over, or not mixing complete, you know, how we say it, not mixing, it's going through a tube, through a coil of pipe. So it's going through and it's cooling down. So hot gas is cooling down and it's going to cool down and turn into a liquid. So liquid, I see it, liquid refrigerant is coming back out of this one. Still a high pressure. On this one, it goes through this little gizmo here, which is a filter dryer there. And you get to one of the business end of thing. This is an expansion valve. This is electronic expansion valve, where it does a magnetic field, spins magnetic field round through four coils, and that spins the inside here around. So you can see our liquid refrigerant going in there. It's going through a small hole called an orifice, and this in here is connected to the suction. So this is a lower pressure. It's going through a small hole. It's going to be a lower pressure the other side, and it's lowered the pressure of the refrigerant enough in this ambience, the 2, 3, 4 degrees here. That's all frosty there. I'll scrape some of it off. So you can see it's lower pressure and it's boiling off. So to boil off, it needs heat energy from the air. So it's cooling the air down and moisture in the air squeezing around the pot. So that in turn will then disappear. That is another filter dryer of some description. Then down to there, that's called a distributor. So one pipe in, and I think it's got 3 or 4 pipes coming out, but it's the distributor thus evens the flow between each of the pipes. It's also pointing down as well, either pointing down or up, not like sideways, because you might not get an even flow through all the pipes. So those 4 pipes, or 3 pipes, however many are there, go to sections in this coil here. Come back up, sections in this coil, so it will zigzag up and down the coil. You might even see there, lines of frost. That's where it starts to go in, boils off, maybe low enough temperature to draw moisture out of the air. It zigzags through a few of them, and eventually it will come out on this pipe. That's our suction pipe. So this goes back down here to the four-way valve, and then it will hop through that middle one. Down here, there's a temperature sensor there. There's also a low pressure switch there. So if you lose refrigerant or anything get wrong with it, causing a low pressure fault, you know, you got to shut down and then back down into the converter. I won't take this off, but there's what's called an accumulator. Go to that first, so it doesn't have any chance of sucking liquid refrigerant in. Because you can't compress the liquids, you might damage your compressor. Then back into the compressor and back out. So I just had to weigh the refrigerant out on this one, just recharge it. So there's a service port there, and you can see, just get in the shadow, it's R32. This is a 410A scale, but they're pretty similar. So you can see that is actually evaporating about -6. So what that means to say is that coil in there, the refrigerant is going in as a liquid, but it's changing state at -6 degrees. And it's doing that, excuse me, the air's blowing through the coil and it's taking heat out of the air so it can boil off. And then that heat gets transferred back the other way into this heat exchanger to heat the water up, opposite way around. I haven't got a gauge on that one, but I mean, if you feel the pipe coming in, let's say that's about 50 degrees maybe, that might be changing state about, well, we only just started this up, about 35 degrees maybe, something like that. So that's how that one works, or this one anyway. This is an inverter compressor, so it speeds up, slows down as it needs, in conjunction with that valve opening and closing as much as it needs. It will tell that by there's a few temperature sensors around, as long as it's trying to flood this coil with refrigerant, really keep it as most efficient as it can. Not on this one. Some of these fans are speed controlled as well. This is just on off speed on this one, but some speed up and down as well. What it will do as well, when it gets to a certain temperature on the coil, about -3, some -7 maybe, it will stop and it will defrost the coil. So what it will do then is it will operate this valve, slide it across, so the hot gas will then be diverted through this pipe. Remember, that went into the coil, so hot gas will go into the coil, it will cool down, come out as a liquid in here, back through this expansion valve, back into the heat exchanger, so it's taking heat out of the water in effect, coming back down as a cold low pressure gas in that way, back that way down to the compressor. So that's how it defrosts. It'll do that a quarter of an hour, 10 minutes maybe, quarter of an hour at the most, till the coil's got to about 13 degrees, and then it'll stop, sit for a few minutes, then go back into heating again, heating mode. I hope that all makes sense. Good to me anyway. Cheers.